Well, let's wrap up this section with a big honkin' Lewis structure. And no, we aren't going to be talking about how you would draw this Lewis structure, although this Lewis structure is going to make more sense to you after the lab, I think, this week. But you need to be able to look at this Lewis structure, and if I point to certain atoms, you need to tell me the geometry around that atom. So picking on the first one, I'll ask this in the form of a question, I think. Picking on this one right here, oops, goodness gracious. Picking on this one right here, how many sigma bonds and lone pair electrons are associated with this carbon atom? I'm getting 4, okay? The question here is then, we're kind of building up to structural geometry, but what I usually do is, what is the orbital hybridization then if you have 4 things associated? In this case, they're all 4 sigma bonds, but they could be lone pair electrons total. That is sp3 orbital hybridization. Then the last question is geometry. What geometry is associated with sp3 orbital hybridization, or 4 things extending from an atom? The answer, dun dun dun, is tetrahedral. Now let's pick on nitrogen, this nitrogen over here. So with this nitrogen over here, how many sigma plus lone pair electrons do you have? Well, I'm getting 1 sigma and 1 lone pair electron, so I get 2. What sort of orbital hybridization do you have then? I'm like an sp for that. And then what sort of bond, not bond angle, what sort of shape do you have? The shape is linear. See how that all works? They all kind of go together. So let's pick on this carbon up here. So how many, this one right here, how many sigma bonds and lone pair electrons do you have? Well, I'm getting 1, 2, 3 sigma bonds plus no lone pair electrons. I'm getting a total of 3. What sort of orbital hybridization is that? I'm liking sp2. So what sort of shape is that? I'm liking trigonal planar. See how that works? Interpreting a Lewis structure. And then last but not least, we have this oxygen over here. All right, how many sigma bonds and lone pair electrons do you have? I'm getting 1 sigma bond plus 2 lone pair electrons for a total of 3. Very good. So what sort of orbital hybridization is associated with 3 sigma bonds and lone pair electrons extending from an atom? I'm liking sp2. Okay. So again, what sort of shape do we have? Trigonal planar. See how that works? I have another set of questions associated with the same Lewis structure. We're going to kind of go from left to right. I'm kind of piggyback on what we did a minute ago. This is all about bond angle. What's the bond angle? So for this one right here, you guys, we came up with sp3 orbital hybridization, didn't we? Because we had 4 things extending. So of course the bond angle, what's the bond angle? 109.5. Very good. So it's tetrahedral. We did not do this carbon atom, so we kind of need to knock it out right quick, if that's okay with you. Okay. For that carbon atom, how many sigma bonds and lone pair electrons do we have? I get 1, 2, 3 sigma bonds plus no lone pair electrons. I get 3. So what sort of orbital hybridization do we have? I get sp2. Again, that little table that was early on in this part, I think that is kind of nice. This is what we call the second row in that table. So sp2 is trigonal planar. Trig. Now you can't abbreviate it, but I can. Planar. So what sort of bond angle do we have? 120. Okay. The last one we didn't do earlier too, so let's go ahead and knock it out. So in order to understand this bond angle right here, we need to understand what's going on with that carbon atom. So how many sigma bonds do we have extending from that carbon atom? Oh, sorry, I should say sigma bonds and lone pair electrons. Well, this carbon atom has 1, 2 sigma bonds. Remember, you kind of put on blinders. You just focus on the atom of interest. This triple bond is 1 sigma, 2 pi. So I get 2 sigma bonds, no lone pair electrons directly around that carbon. So I get 2. What sort of orbital hybridization do we have? sp. What sort of shape do we have? Linear. To me, I kind of think through all of those things. And then I finally get to, with a linear shape, what sort of bond angle are you looking at? 180. I call it the hot dog bond angle. Very good. So these are the problems then associated with this part.